Some of the things that you should know about fronts include the symbols, how they form, and the weather that are associated with them. The first symbol here is a warm front. A warm front forms when a warm air mass overtakes a cold air mass. In the image just below the symbol of the warm front, you can see that the warm air mass is the one that is doing the pushing. The warm air is pushing over the cool air. This is why it is called a warm front. You can also see that the slope of a warm front is very mild. A warm front you can tell is approaching from a far distance away by the cirrus clouds that you see far in the distance of that warm front approaching. Once the warm front is near you, you will be experiencing nimbostratus clouds. These nimbostratus clouds will bring some light rain over a large area, but no big, huge thunderstorms, but they will be persistent over a long period of time. When we have a cold front, the cold air mass is doing the pushing. The symbol seen here shows us that the cold air is doing the pushing. When we have a cold front, we are going to have the formation of cumulonimbus clouds with large, heavy storms, lots of rain, and lightning and thunder accompanying the storm that is going to form directly above where the formation of the front occurs. When we have a stationary front, we have a cold air mass and a warm air mass that are both pushing on each other, and neither of them are moving. In this kind of front, we can see that we also get the formation of cumulonimbus clouds. When we have an occluded front, we have a cold front and a warm front that have formed, but the cold front is overtaking the warm front. When this happens, we can see that the cold air is pushing and cooler air from behind the warm front is far to the right, and the warm air mass that was within them gets pushed upwards. Occluded fronts are also likely to form large amounts of precipitation, or if unstable, they may also form cyclones or tornadoes. Air masses are named according to the location that they form. For example, continental air masses form over the land. Because of this, they will be dry. Maritime air masses form over the water, and because of this, they will have moisture associated with them. Air masses are also named according to the temperature of the location where they form. Tropical air masses will be warm, while polar air masses will be cool. Notice that we can also abbreviate the names for the air masses. For example, a maritime polar air mass would form over the water, which would make it moist, and if it is forming from the north, would be polar. And we can abbreviate that with a lowercase m and a capital P. If a maritime tropical air mass is forming, it would be forming near the equator and over the water, which would mean that it is warm and moist. And we can symbolize that with a lowercase m and a capital T. We use a lowercase c to abbreviate continental, a lowercase m to abbreviate maritime, a capital T to abbreviate tropical, and a capital P to abbreviate polar. There are three main things that we need for the formation of clouds. There needs to be moisture in the air or water vapor as a gas. We will need a condensation nuclei, and we will need the air to cool to the dew point temperature. Let's talk about moisture first. This means that we are going to need to have enough moisture in the air so that the water vapor can condense and change its state of matter from a gas to a liquid. A condensation nuclei is a solid particle that the water vapor can go from the gas state to the liquid state on or condense onto. These condensation nuclei can be dust particles, pollen particles, smoke particles, or even salt particles floating in the air. Then we need the water vapor to go from the gas state to the liquid state, which means that we need the air to cool to the temperature where this will happen. This would be the dew point. The dew point temperature is the temperature at which the air is at the point at which it will be saturated and go from a gas state to a liquid state. This will happen as air rises up. Warm air will rise, and as that warm air rises, it expands. And as it expands, it will then cool so that the condensation can occur and it can go from a gas to a liquid. We can name clouds according to their height and their form. We have three main words that we use for height. Cirrus means high altitude, alto means medium altitude, and stratus means low altitude. There are four main words that we use to describe the form of the clouds. Cirrus means wispy and feathery, cumulus means puffy, nimbus means that rain is associated with the clouds, and stratus means that they have a layered, foggy appearance to them. If you recall from the section about the formation of clouds, we need to have air rise up so that it will expand and cool and condensation will occur. In order to have condensation happen and lift happen, there are actually four different ways that we can get the air to lift up. The first way is orographic lift. This is lift where the air gets pushed upwards because of a mountain in the way of the movement of the air. The second is frontal wedging. This is where one air mass pushes on another air mass, just like how the formation of fronts occurs. Convective lift occurs when one location warms at a different rate, and so the rising of the air is going to occur at different rates. And then convergent lift is when the air masses come together, and when they collide, they cannot go down because the ground is in the way, and so the air must go up. All of these will create lift so that the air rises, and when it rises and cools, it expands, and then we will have the formation of clouds. Orographic lift will produce a rainy side on the windward side of the mountain and dry, warm air on the leeward side of the mountain. Finally, we should know the definition of relative humidity and dew point. Relative humidity is the amount of water vapor in the air compared to how much it can hold at that particular temperature. We want to remember that warm air can hold more moisture in it than cold air, so that when the air rises and it cools, it then must condense because that cold air cannot hold as much moisture. The dew point temperature is the temperature that the air has to cool down to in order to get that saturation to 100%. When we have saturation at 100% or our relative humidity at 100%, then we will get the formation of clouds and precipitation. The dew point temperature is usually the temperature that is reached when the bottom of clouds begin to form. That is because this is the location where condensation can begin because the air is saturated, because it's at the temperature where the air is holding the most it can at that particular temperature. If we have a warm air mass that is at 70% relative humidity and cold air comes in, which can hold less moisture to it, our relative humidity is going to go up because cold air can hold less moisture. So our relative humidity, if we originated with warm air and cold air comes in, our relative humidity might go up to 100%, and we may cool down to that dew point and have the formation of clouds. Now, if we have a cold air mass that is at 70% relative humidity and warm air moves in, because warm air can hold more moisture, now our relative humidity is going to decrease. With that warmer air, our relative humidity might drop to 50 or 20%. That's going to be a low relative humidity, and we're not going to have the formation of clouds. Whereas with the other situation where we had warm air and cold air came in and our relative humidity increased, that may drop us down to the dew point, causing the formation of clouds. Finally, we should know that a sling psychrometer can be used to determine the relative humidity and the dew point temperature in a location. A sling psychrometer is made up of two thermometers, a wet bulb and a dry bulb. We look at the dry bulb reading and read down the left column to the temperature, and then we read across to the difference between the wet bulb and the dry bulb temperatures. The difference between the wet bulb and the dry bulb temperatures is called the wet bulb depression. This difference determines what the relative humidity is, or the dew point temperature. The greater the difference between the wet bulb and the dry bulb, the lower the relative humidity. The closer the wet bulb and dry bulb are, the higher the relative humidity. If there is no evaporative cooling and the wet bulb and the dry bulb are the same temperature, then the relative humidity is at 100%. We can then do an example. If the if the air temperature is at 0 degrees and our difference between our wet bulb and a dry bulb is 3 degrees, we can see where these intersect to find our relative humidity.